Hello, Period 4 Honors Pre-Algebra. It's Miss Dewey Hoffman here for your second lesson. The quote today comes from Horseradish, Bitter Truths You Can't Avoid by Lemony Snicket from page 37. Most schools have a system of loud bells which startle the students and teachers at regular intervals and remind them that time is passing even more slowly than it seems. Today's math lesson is going to come to you from Chapter 1, Lessons 3 and 4, so make sure you're paying attention. Quick vocabulary, evaluate. To evaluate an algebraic expression, that's supposed to be expression, so add an ION at the end. You first replace each variable with the given number, then use order of operations to simplify. So for this first example, I'm going to replace G with 8 and H with 7, and then do some math. So I still have the 6, the G is now an 8, plus H, which was 7. So then, order of operations, I got to do the parentheses first. So 8 plus 7 is 15. And 15 times 6 is, well, 15 times 2. I'm going to show you some quick tricks. 15 times 2 is 30. So if I do that 3 times, 30 plus 30 plus 30 is 90. So there you go. You're more than welcome to check my math. So that's your first example problem. Next example problem, we've got 2 times x times y minus z. Well, x is 4, y is 3, z is 1. So I've got 2 times 4 times y, which is 3, minus z, which is 1. Alright, so 2 times 4 is 8. 8 times 3 is 24. 24 minus 1 is 23. There we go. And don't forget to box your answers. Alright? Alright, ready for the next example problem? The next example problem has a fraction bar in it, which means it kind of acts like a grouping symbol. Alright, so R is 13, S is 11. So we have 13 plus S, which is 11, divided by 2. And since we've got the fraction bar, we do have to do the addition first, before the division, because of that fraction bar. So 13 plus 11 is going to be 24. 24 divided by 2 is 12. So all very, very, very easy. Alright, let's go ahead and move on. Alright, so sometimes they're not going to give you the expression and you're just going to have to figure it out. So we have eggs that can come in cartons of 18. So if I make E the number of eggs I need, my expression would be E divided by 18 is equal to number of cartons of eggs I need. Alright, I'm going to move down here. So, let's say I needed 24 eggs, and I divided that by 18. I would need, because I can go ahead and simplify this, 18 goes into 24 once, right, because the 24 goes in the house, 18 goes outside of the house, and how many am I going to have left over? Well, I'm going to have 6, so 6 over 18. So basically, since I can't buy half a carton worth of eggs, I'm going to need 2 cartons. Okay, but let's say I needed 36 eggs. 36 eggs. Well, 36 eggs means that I actually need 2 cartons exactly, because 18 goes into 36 twice exactly. So here's the algebraic expression that I created, and then depending on how many eggs I actually needed, it would tell me how many cartons I then need by doing that problem right there. Okay, next example problem. Say a store pays $29 for a case of drinks. Write an algebraic expression for the cost of C cases. So, and then we're going to find the cost of 5 cases. So if C is the cost of if C is the number of cases, if we multiply C by the cost of 1 case, we're going to get the total cost of C cases, right? So that's the algebraic expression they're looking for. right? We're going to write an algebraic expression, and then we're going to simplify using the given information. So the given information is that we then have 5 cases. So C, since that's the number of cases, is going to be 5. So it's going to end up being 29 times 5. So with my handy dandy calculator, I did 29 times 5, which equals $145. So if I were to buy 5 cases at $29 each, it's going to cost me a whopping $145. Hopefully I'm going to make some profit off of that. Alright, next slide. So we're on to lesson 4. Just to review, if we have 0 in the middle, this is a number line by the way, if we have 0 in the middle, positive numbers are on the right and negative numbers are on the left. So it would be like positive 1, 2, 3, 4, and this would be negative 1, negative 2, negative 3, negative 4. Alright? So integers are whole numbers and their opposites. So these over here on the right side are the positive integers, and on the left side are their opposites, which are the negative integers. Absolute value, this should hopefully be reviewed, is how far a number is from 0. So if we were to look at 1 and I asked you what the absolute value of 1 is, the absolute value of 1 is 1, because 1 is 1 unit from 0, whereas 2 is 2 units from 0. Alright? But the same thing can be said for the negative integers. Negative 1 is 1 unit from 0, therefore the absolute value of negative 1 is 1. And we use absolute value bars to denote absolute value. So there's an absolute value bar. Alright, so they're vertical lines, and they're vertical bars on either side of either a number or a group of numbers in an operation. And I read this as the absolute value of negative 1 is 1, because, again, negative 1 is 1 unit from 0. Alright, so then if I have, just real quick, opposite. So if I have negative 2, and I want to know what the opposite of negative 2 is, I look at what number is the same distance from 0, so in this case 2 units from 0, but on the opposite side of the 0. So a number that is 2 units from 0, but on the right side of the number line would be 0. So I could say the opposite of negative 2 is 2, because negative 2 is 2 units from 0, and positive 2 is also 2 units from 0, but again on the opposite side of the 0. Alright, so that is number lines, absolute value integers, and absolute values and opposites. Alright, so now let's go ahead and do some math with absolute value. So again, just in general, absolute value turns whatever number is inside of the absolute value bars into positive. So sometimes that matters and sometimes it doesn't, but you get the idea. So if we have 14 minus the absolute value of 9 plus 4, I'm going to treat the absolute value as grouping symbols. So kind of treat absolute value like parentheses, but they actually do something other than group things together. So 9 plus 4 is 13. The absolute value of 13 is 13, because 13 is 13 units from 0. So once I've gone ahead and do that, the absolute value bars disappear, because really nothing changed, but that's okay, I can still show it. And then 14 minus 13 is 1. There you go. So that's your example problem there. Now, since grouping absolute value bars act like grouping symbols, when you have them right next to each other, a number right next to an absolute value bars, it means multiplication. Alright, it means multiplication. So this is said as 5 multiplied by the absolute value of 4. Well, what is the absolute value of 4? the absolute value of, negative 4 is 4. So it's like saying 5 times 4, because the absolute value of negative 4 is 4. So that would be 20. All right, positive 20. All right, and just a quick comparison, we can use inequalities or inequality to come up with, to compare absolute value. So the absolute value of negative 7 is positive 7, because negative 7 is 7 units from 0. Therefore, the answer is 7 on that side. And then here we have something that's a little confusing. We're going to read this as the opposite of the absolute value of negative 8. So whenever you have like a stray negative sign there, you say it's the opposite. So we have the opposite of the absolute value of negative 8. So the opposite of the absolute value of negative 8, well, the absolute value of negative 8 is positive 8. But the opposite of negative 8, the opposite of positive 8, because this is now positive, the opposite of positive 8 is now negative 8. So which one is bigger, 7 or negative 8? Well, 7 is greater because it is further to the right. All right? Things that are greater are on the right side of the number line, and things that are smaller or have less value are on the left side of the number line. All right, guys, that finishes it up. I hope you had a great 3-day weekend. Bye.